Okay, in lesson 18, we will continue talking about graphs. And in this section, the topic is graph transformations. So, how to start with a basic graph and modify the function and see what the new graph will look like. So, this is why I said in the previous lesson that you should know at least some of the basic functions, because then what we're going to do is we're going to start with some basic functions such as the absolute value function or this function or I don't know, this one, the square root function. And then we're going to modify it a little bit and see if we can graph it without too much work. But just starting with the basic or parent function. So if you know the basic shape without modifications, then we should be able to take that one and modify it a little bit and make the new graph of the new altered or modified function. So that's the whole deal. Okay. Um, so there's several things you could do to a function. The very first change or modification that you could do to a function or to the graph of the function is to shift it up. This is or down. This is called a vertical shift. And well, visually, right, it's just moving the whole thing up or down uh, by a certain number of units. But if what you have is a formula in front of you, the formula for f, then shifting up or down is tantamount to just adding a number. So if you add, let's say, k, that means you're going to move the graph vertically by k. If k is positive, then that means you move the graph up by k numbers, by k units. So if k is 5, then you move the positive 5, then you move the whole graph up by 5 units. If k is negative, let's say -5, so then that means you move the whole thing down by 5 units. So you just by adding a number outside of the formula, you see this is uh, you take the whole formula and you add a number to it, then you move the graph up or down. And I say outside of the formula because some modifications are going to happen inside of the formula, like where x is inside of the f. And that's going to come up in a little bit. But for now, if you add a number outside of f of x, then that means you move the whole graph up or down. Okay, so here's the first example. Suppose I have the graph of a function. I don't have much of a formula for the function, but I have the graph. And supposing I know the formula and I consider a new function by adding 2 to the formula, can we sketch the graph of that? So it'll be part A. And then part B, sketch the graph of the function that you would obtain if you subtracted 3 from the formula from f of x. Okay, so let's start with A. So I'm gonna sketch the graph of this. Y equals f of x plus 2. And this is, you see this is y equals f of x. So that one right there is y equals f of x. So if I add 2 to f of x, that means I move the whole thing up by 2. Um, and all you have to do really is choose a few key points that will help you keep track of everything. So, for example, I'm going to use this, that, and that. So those corners are going to be my key points. So I take this one and I move it up by 2, and I end up right there. And then I take this one and I move it up by 2, ends up right there. And then I take this one and I'm going to move up by 2, and this one, and you move it up by 2. And then you connect the dots following the same shape, because this really should be exactly the same shape. All you're doing is moving it up. Um, and then you're going to have the graph of the new function, of the modification. So you have that, then connect to these two, then connect to those two. Okay, and that is the entire graph shifted up by 2. So that is the graph of y equals f of x plus 2. This one right here is the graph of y equals f of x. So add 2 means move the whole thing up by 2. And that's it. So that is A. Now, B says we have to sketch the graph of y equals f of x minus 3. So for that one, now minus 3 means you move the whole graph down by 3 units. So again, I'm just going to move some key points. Let's start by moving this one. 3 down, 1, 2, 3, 1. 1, 2, 3 there. 1, 2, right, 1, 2, 3 there. And 1, 2, 3 there. So everything is moved down by 3. And now let's connect the dots. So connecting those two, we get that there. Now let's connect to these two. And now let's connect to these two. Okay. And that is the graph of y equals f of x minus 3. Move the whole thing down by 3. Okay, now let's talk about horizontal shifts. So the previous page, the page that we just did, was about vertical shift. If you add a number outside of the formula, it moves the graph up or down. Now, horizontal shift, moving the graph left or right, you see happens when you add or subtract a number inside the formula where x is, and that is the difference. If you subtract or add a number, so it could be a plus or it could be a minus. The important thing is going to be the sign. I'm going to tell you in a minute. But if you add or subtract a number inside of the formula, then that's going to be a horizontal shift. It's going to be a horizontal shift. Okay. So if h is positive and this there's a minus in there, so if h is positive combined with this minus means the whole thing is going to be minus, then the graph moves right. Okay, that is a little bit weird because I'm saying if h is positive and then you combine it with this minus in there, you get a negative. You would think that having negative means you move left, but no, it actually moves to the right. So that is going to be an important difference between modifications that happen horizontally and modifications that happen vertically. So for modifications that happen vertically, meaning outside of the function, they always behave the way you would expect them. So plus 5 means you move the whole thing up 5. Minus 5 means you move the whole thing down 5. But however, for horizontal modifications or transformations is the opposite of what you would think should be. So having a plus 5 inside means the graph is gonna move left by 5. If you have a minus 5 inside, the whole thing is gonna move to the right. Okay, so it's gonna be the opposite of what you would expect. So if you have h is negative, then this negative combined with that, the fact that h is negative combined with this other negative gives it positive, and the whole thing will be positive, so the graph moves to the left. Okay, so one more time, whenever uh, you have to think the overall of the overall thing. If what you have is a plus, let's say a +5 inside, the whole thing moves left. If you have a -5 inside, the whole thing moves right. Okay, so plus moves to the left, minus moves to the right, which is a little bit opposite of what you would expect, because negative numbers are on the left, but if you have a negative number inside, you move to the right. Okay, so all right, now let's get to it and draw the first example. So suppose I have y equals f of x, so that's the original graph. I want to sketch the graph of y equals f of x minus 3. So I'm modifying the original function, which is f of x. I'm modifying it by subtracting 3 inside. Okay, subtracting 3 inside, minus 3, there's a negative, is going to move the whole thing to the right. So that means I'm going to take all the key points and I'm going to move them to the right. Then I'm going to connect them, and voila, I have my graph. Okay, so I'm going to move that one to the right by 3. 1, 2, 3. Now, that would be the next one. 1, 2, 3. The next one is this one. 1, 2, 3. And the next one is this one. 1, 2, 3. Okay, now let's connect those dots, and that's our graph. There. And there. Okay, that is the graph of f of x shifted 3 to the right. So y equals f of x minus 3. Okay, now let's draw part B. Part B, I have y equals f of x plus 2, where the plus 2 is inside f. That one's a plus 2, so instead of moving to the right, it actually moves to the left. So now we just move the whole thing to the left by 2 units. So 1, 2 right here, 1, 2 right here, 1, 2 right here, 1, 2 right here. Okay, now let's connect. Okay, and that's it. The graph of f shifted to the left. So that means you add 2 inside. So that one is the graph of y equals f of x plus 2. Okay, good. Okay, now we would like to sketch the graph of a function starting from the formula. So I don't have a graph in front of me to begin with. There's nothing here, as you can see. But I have the formula. And you have to realize, you see that that the basic starting point is the square root function, and the square root function has been modified a little bit. So if you realize that, then you can sketch this. So the basic function is y equals f of x. I mean, sorry. Yeah, y equals f of x, where f of x equals square root of x. So the basic function is the square root function. Okay, note that there's two modifications. One is inside the square root. One happens inside and the other one happens outside. Okay, the one that happens outside is a vertical shift. Remember, things that happen outside, when you add or subtract things outside, then that means you're moving the function up or down. So this thing is telling me that I'm moving the whole thing up by 2. And then if you see this minus 1, that is happening inside the original function, the square root function. That happening inside, but when it happens inside is a horizontal transformation and it does the opposite of what you would think. So subtracting 1 minus 1 is going to move the whole thing to the right. And then you have these two things you see in the same formula, so that means both things are going to happen at the same time. Okay, so in order to begin the graph, we're going to have to take a moment and sketch, just for our guidance, this is not truly needed, but sketch the graph of the basic function, square root function. And that's one of the functions that was in the previous lesson. This one, remember, you should know what it looks like. It looks like this. 0, square root of 0 is 0, at 1, square root of 1 is 1, at 4, square root of 4 is 2, and so on. So I'm going to sketch that real quick. Okay, so I have at 0, the square root of 0 is 0, at 1, the square root of 1 is 1, at 4, this is it 1, 2, 3, 4, the square root of 4 is 2, and then the square root of 9 is 3. So this is 9, and this is 3. Okay, so I'm going to connect those, curvy. Okay, more or less. Okay, not too bad. All right, so that's the graph of the square root function. That's a sketch. All right, now we're going to sketch the graph of that. And remember what I said, there's two modifications, one horizontal and one vertical. The one that is horizontal is the one that happens inside, and it says -1, and because horizontal transformations have moved in the opposite direction, so -1 means to the right, and then this one you move up, so you can do both at the same time. Okay, so I'm going to take each and every one of these key points that I have right here, and I'm going to move them according to the instructions. So first, this one, it says you move 1 to the right and 2 up. So 1 to the right and 2 up. There. 1 to the right and 2 up. 1 to the right and 2 up. So now you do the same thing with every single point. 1 to the right and 2 up. 1 to the right and 2 up. 1 to the right and 2 up. And then 1 to the right and 2 up. And then you connect them. And there's your graph. I mean, your sketch. The sketch of your graph is not perfect, but more or less. I mean, my curves are not that good, but all right. Basically, it should look exactly the same, but just shift it up. And I mean, to the right by 1 and up by 2. Okay, so that would be the graph of A. Okay, y equals, which is y equals square root of x minus 1 and then plus 2 outside. Okay, now let's sketch the graph of B, which is f of x equals square root of x plus 2 minus 3. Okay, the minus 3 moves the whole thing down by 3 units. And then the plus 2, which happens inside, is a horizontal movement. And the plus 2 means you move to the left. Okay, so now we're going to move everything 2 to the left and 3 down. 2 to the left and 3 down. 2 to the left, 1, 2, and 3 down. 1, 2, 3. 2 to the left, 1, 2, and 3 down. 1, 2, 3. 2 to the left, 1, 2, 1, 2, 3, and 3 down. And this one, 2 to the left, and 3 down. 1, 2, 3. Okay, you connect. And there's the graph. Again, it's a sketch because I'm not that good with curves. But okay, cannot use my ruler for that. All right, that's it. That would be the graph of b. In other words, is the graph of y equals square root of x plus 2 minus 3. So you could use, y equals f of x, so you could put here also f of x equals square root of x plus 2 minus 3, or here f of x equals square root of x minus 1 plus 2. Okay, so that's how you start with the basic function and then modify it, move it up or down, left or right to get the new graph. Okay, next page. Another transformation that you could do to a function, to its graph, is to reflect it across, usually across either the x-axis or across the y-axis, or you could use the word through, over, about, across. I've seen all those. Okay, so if you want to reflect the graph about the x-axis, then you multiply the function outside by -1. You put a negative, so multiply the whole thing by negative. So the negative is outside. That takes the whole thing and reflects it about the x-axis. If the negative is inside, then the whole thing is reflected about the y-axis. Okay? So if the negative is outside, you see things that happen outside is a vertical movement transformation. So that's why if the negative is outside, is about the x-axis, because the things that are up move down to the opposite side of the x-axis. And then if the negative is inside, then it's a horizontal movement, and things that are, let's say here, they move horizontally to the opposite side of the y-axis. Okay, so now let's sketch the graph of this. Let's sketch the graph of f of x equals negative square root of x plus 1 plus 2. Starting again with basic function y equals square root of x. Again, this is a modification of the squared function. So let's take a moment to again draw the sketch of graph of the draw the graph of that real quick. So at 0 you get 0, at 1 you get 1, the square root of 1 is 1, 2, 3, 4, the square root of 4 is 2, the square root of 9 is 3. Okay, so more or less that's what the graph looks like. That is y equals square root of x, and that's the basic one. This is a modification of that one. And you see there's a lot of stuff going on in there. There's a plus 2 outside. That moves the whole thing up. There is a plus 1 inside. That moves the whole thing to the left. Remember, inside is the opposite of what you would think. So inside a +1 moves everything to the left, not to the right. And then there's a minus outside of this, which is going to reflect that piece. And if you follow the order of operations, you should really then do this part first, and then that part, and then that part. We should have done it in the previous ones as well. It would have been better in that case because there was only moving up and down, left and right. It didn't really matter, but really in general, you should try to do it in the order of operations to avoid possible mistakes. Okay, so that's what we're gonna do. So let's start by, I'm gonna do it in 2 steps actually, then 2 or 3, so you can see. Okay, first thing is I'm going to move everything to the, starting with the other operations, start inside here, move everything to the left by 1. So this one, so I'm gonna do that in pencil. That goes there, that goes there, that goes there, that goes there. Okay. All right. So that moves everything 1 to the left. Then we're going to do this negative, which is a reflection. The negative is outside the square root function. So it's going to be a reflection through the x-axis. So that means everything that is up goes down and everything that is down goes up. Everything here is up above the x-axis, so the whole thing moves down. So that reflected above the x-axis stays in place. That one moves here. That one moves to the opposite side, which is here. So if it is 2, now it is -2. If it is 1, now it is -1. If it is 3, it's now going to be -3 here. And so on. It's the perfect mirror image, it's a reflection. So then you connect these. Okay, so let me label these. The first step I did was y equals square root of x plus 1. Then the one I just drew would be adding the reflection, negative square root of x plus 1. And now we finish it off by adding the 2. Adding the 2 will move the whole thing up. This one is going to move the whole thing up. So I'm going to take that one and move everything up, and now I'm going to do that one with the marker, purple one. So now move this one up. So 1, 2, right here. 1, 2, right here. 1, 2, right here. 1, 2, right here. Now you connect those dots, and that's the graph we're after. Okay, sometimes if there's too many things going on, it is better to just do it one step at a time, or maybe 2 at a time, but not the whole thing. You see, there were 3 things going on here. Doing all 3 at the same time could drive you a little crazy and make you make mistakes. There's too many things going on. Just take it one step at a time. Do one movement, then do the next one, and then do the next one. All right, so that is the graph. Okay, there's 2 more um, things that you could do. You could stretch a graph, or you could compress it. It's kind of a variation of the same concept, and that happens when you multiply. So right now we have been doing only adding and subtracting, and then just adding, slapping on a negative sign, and, and we have seen what those things do. But now the last thing we could do is multiply by a specific number. Okay, if you're multiplying a function outside by a specific number, remember doing things outside of the formula affects the graph vertically. So that is multiplying by a number outside is going to be called a vertical stretch or compression. If so, which one is which? If a is bigger than 1, then we say the graph is being stretched. So it's going to look elongated, like longer. Um, and then if a is between 0 and 1, then that's going to be a compression. It's like the graph is becoming flatter. Okay? And if a is a negative number, then it's going to be a reflection combined with either a stretching or a compression. So basically you have a negative sign and then a number that could be bigger than 1 or between 0 and 1. And of course, a equals 1 is not included anywhere because a equals 1 doesn't do anything. Multiplying by 1 does nothing. Okay, so that's it. If a is bigger than 1, you are stretching the thing, making it bigger. If you are multiplying by a number between 0 and 1, you're compressing it or shrinking it, making it flatter. And then if you multiply by a negative number, then you consider the actual number and its sign separately, and you say that's a combination. Because the negative is going to be a reflection, and then the number is going to be either a compression or stretching. Okay, so now let's start by doing the examples where the numbers being multiplied are outside, which means the vertical transformation. Okay, so let's start with this graph right here. Okay, so that is the graph of y equals f of x, and the part A says sketch the graph of y equals 3 times f of x. So that means basically that we're multiplying the y coordinate by 3. Okay, so if you have a point that is on the graph, because you're multiplying outside and y equals f of x, that means you're multiplying the y by a. You see, you're not multiplying the x by a. You're multiplying f of x, and f of x is y, so that means you're multiplying the y by a. So that means the new point is going to be to just take the y coordinate and multiply by a. So here, then, if I'm multiplying f of x by 3, that means all I have to do is take that point and multiply the y coordinate and the y coordinate only by 3. Same with that, multiply the y coordinate by 3. Same with that, multiply the y coordinate by 3. And same with that one. Okay, so that's it. So let's do it. So this is going to be the y coordinate of this point is 2. Multiplying that by 3, that's going to become 6. The x coordinate stays the same, so that's going to be 6. Okay, so that's the first one. Let's now sketch the next key point, this one. So the y coordinate of that is 0. So 0 times 3 is 0. So that means it's the same point. This is here is 3. Multiplying the y coordinate by 3 gives you 9. And then lastly, the y coordinate, this y coordinate right here is negative 2. Multiplying it by 3 gives you negative 6. Okay, now let's connect those points and see what the heck that looks like. Okay, um, let's see. Let's connect these two. Aha. Now let's connect these two. And lastly, let's connect to those two. And that is the new graph. Let me make it thicker if I can. So there, just a little bit. There. Okay, now you can see that better. Uh, Supposed to end right up there, same spot. Okay, so that is the new graph, and you can see that it's the same one that has been stretched. It's like you grab that and you pull it up. You're stretching it. That's what happens. So is stretched by a factor of 3. So that's the graph of y equals 3 times f of x. Okay, now let's sketch the graph of b, which is multiply everything by half. Multiplying by a half, that half is between 0 and 1, uh, so it's going to make it flatter. So it's going to shrink it. It's going to kind of like squeeze it. All right, let's do it. Well, again, is a number that is outside, so all you have to do is multiply the y coordinate by that number. All you have to do is multiply the y coordinate by that number. Okay, so if I have this point, the y coordinate of this point is 2, multiplying it by half gives me 1 right there. The y coordinate of this one is 0, multiplying 0 by half is 0. So again, right there. And the y coordinate of this is 3, multiplying it by half, that's 1.5. So that's going to be right here, 1.5. And then multiplying the y coordinate of this one, which is negative 2 by a half, is negative 1. So right there. And now we just connect these dots. So that, and then this, and then that one. Okay, and that's the graph. And you can see that it's kind of compactified, like compressed. It's like squeeze it down. It's compressed, okay, by half, by a factor of a half. All right, and that's how you do that. Again, just multiply the corresponding y coordinates by the number outside because numbers outside only affect the y coordinate. Numbers inside of the formula affect the x coordinate. And the next example is going to be 1, where the number we multiplied happens inside. Okay, now we're going to give an example of um, horizontal step of stretching and compressing. So this is when you multiply the function by a number, but the multiplication happens inside the function. You see, uh, the constant but which you're multiplying, in this case b, the b happens inside f. So because it is happening inside f, that means it's a horizontal type of transformation. If the multiplication were happening outside, it would be a vertical type of transformation. Okay, so now the compression is going to happen horizontally. It means it's going to be like that. Let me zoom out. So it's gonna happen this way. So the graph is gonna either be squished like that or stretched this way, right? It could be stretched this way. Okay. Um, if you have a point xy, oops, where is it? Xy in the original graph, then the new point, you're gonna get it by simply, now remember this is a vertical, this is a horizontal transformation, so that means only the x coordinate is affected. And remember also that when it's a horizontal transformation, it behaves the opposite of what you would think. So even though you're multiplying by b in the formula, in the graph, the actual transformation that is happening is that the x coordinate is being divided by the constant. So instead of multiplying x by b, you're going to divide it by b because you do the opposite of what you think you should be doing. This is how horizontal transformations behave. If b is bigger than 1, then instead of stretching, like in the vertical case, you're going to be compressing. You're going to be compressing and not by a factor of b, but by a factor of 1 over b. And if b is between 0 and 1, you're not compressing, like in the vertical case, you're actually stretching. And you're stretching by a factor of 1 over b. So for example, let's say b is 2. If b is 2, then that means you're compressing by a factor of a half. That means you're shrinking things by a factor of a half. You're multiplying everything by half. You're reducing everything by 50% horizontally. So you're squishing things uh, horizontally by 50%. If b were between 0 and 1, so let's say a half, then that means you're actually stretching everything by a factor of 1 over 1 half, which is actually 2. So that means you would be stretching everything by a factor of 2. So that means you actually would be like pulling it, stretching it sideways, and doubling the horizontal span, doubling the size. And then lastly, if b is negative, then as before, that means it just has a negative sign and an actual number. So the negative means a reflection, and then you have the number itself without the sign is going to either do a compression or stretching. Okay, so let's do this example. Suppose that that's our original graph. That's y equals f of x. Let's sketch A and B. Starting with A, you're multiplying by 3 inside the function, so there's a horizontal transformation. And because the factor is bigger than 1, the B is bigger than 1, if the B is bigger than 1, you're actually compressing by a factor of 1 over B. So in this case, B is 3, 3 is bigger than 1, so that means we're actually compressing everything by a third. Everything is going to get shrunk by a third, compressed by a third. Okay, and remember, one last time before we get pencil to paper, how you find the new coordinates? Well, if you have a point, x1 on the graph, the new point, you get it by just taking the x coordinate and dividing it by the b. In this case, we're going to be dividing it by 3. Okay, so now let's get to work. So starting with that one, the coordinates of that point, so let me write here A. So I'm going to take this one for example. The coordinates of that point are 2, 2. Okay? And then the way I get to the coordinates of the new point, I'm going to be, you divide the x coordinate by 3. So this is going to be 2/3, 2. So that's going to be, these are going to be the coordinates of the new point. So I'm going to sketch that. 2/3, 2. 2/3, okay, you're going to eyeball this because it's not going to be exact. 2/3 a little more than a half. It's around here, and then 2. So then this is going to be around here. Okay, so 2/3, more or less, 2/3, 2. Alright, now let's grab another point. Let's say this one right here. So this is negative, the coordinates of that one are -1, 0. So to get the new coordinates, we divide the first coordinate by 3. So -1/3, 0. So now the new coordinates are going to be -1/3, so a little less than a half, here, so closer to 0, right there, more or less again, because this is so small. So -1/3, 0. Let's do it 2 more times. So the coordinates of that one, -3, 3. The coordinates of that one are -2 3. So the new coordinates after you make the transformation are going to be, you take the x coordinate and divide it by 3. So this is going to be -1, 3. -1, 3 is right here. -1, 3. And lastly, the coordinates of this point are -6, -2. So you're going to take the x coordinate divided by 3. So this is -2, 2. -2, 2. This is right here. Wait a minute. -2. Oh, sorry. That I was like, there's something weird. -2, -2. Okay, -2, -2. -2, -2 is right here. -2, -2. Okay. Now let's see. Let's be careful joining these dots. So joining these two, you will get this. Then let's join these two. And then we join these two. Okay, and that's the new graph. You can see these are the three legs, 1, 2, 3, then 1, 2, 3, and everything is squished like that. The height of every point is still the same, but everything is being compressed, um, and the horizontal span of the whole thing is a third of the size. Okay. All right. So that's how you do it. So it is, um, when the numbers are not precisely like so easy to keep track of, you could do a table like I just did here. In the other ones, we just kept track of it in our heads. But you could also write it down, and then it might be easier for you. So that's A. Now let's do B. I'm going to do the same thing. So now we're going to sketch the graph of y equals f of 2/3 x. 2/3 is happening inside, it's a horizontal transformation, and instead of um, multiplying by 2/3 like you're doing in the actual formula, remember that in the graph the effect is that you divide by 2/3. Okay, so here's the list of the points. So these are actually the same points, so let's see. So we're gonna divide the x-coordinate by 2/3. Dividing by 2/3 is the same as multiplying by 3/2. Dividing by 2/3 is the same as multiplying by the reciprocal, which is 3/2. So we're going to take 2 divided by 2/3. That's the same as multiplying by 3/2. 2's cancel, so you get a 3. So that means the new coordinates are 3, 2. 3, 2. Okay, 3, 2. Let's graph that. 3, 3, 2. Okay, this is going to be a stretching because 2/3 is less than 1. Um, Instead of a compression, is a stretching. Remember, in the horizontal case, it's always the opposite of what you would think. Okay, so now we got the first point. Let's do the next one. -1, 0. So -1 divided by 2/3 is the same as saying -1 times 3/2. So this is going to be -3/2, 0. -3/2, -3/2, that's like -1.5. -1.5 right here. Ah, -1.5, 0. Okay, now let's do the next point. The next point is this one right here, -3, 3. Divided by 2/3 is the same as multiplying by 3/2. -3 times 3/2 is, what's that? That is -9/2, which is -4.5. So -4.5. -4.5, where is that? -4.5 is right here. Oops, let me write that. -4.5, 3. Okay, -4.5, 3. Right there. Okay, then we connect. Okay, good. It's looking good. And then one more point. -6, -2. Multiply -6 by, well, -6 divided by 2/3 is the same as saying -6 times 3/2. This is -18 over 2, which is -9. So the point we get is -9, -2. So -9, -9, that's -9. -2 is right here. Okay, now let's join the dots. There. And that's the new graph, and you can see that it has been, from the black one, it has been stretched or pulled to the sides. The height of every point is still the same, but it has been elongated. By how much? Well, by a factor of 3/2 or 1.5. Okay, so that's it. Okay, now we're going to do, we're going to go over this. This page doesn't really have any examples, but it's like a little bit of a summary of things. in the form of a table. So here is a summary. If you have a number that is being added outside of f of x, then that is a vertical shift. The graph moves up or down, and it moves in the way you would think. If you're adding a positive number, um, then it moves up. If that's a negative number, it moves down. In terms of the coordinates, means if you have a point, then you add k to the y. Okay, so you move the y changes, the height of the point changes up or down. So you add k to the y. This k you just add it to the y. The x stays the same. Okay, if you multiply f of x by a number outside, then again that's a vertical transformation. And if you have a point, then all you have to do is multiply the y by the number. If a is bigger than 1, that is stretching. If a is between 0 and 1, that is compressing, a compression. Uh, and lastly, if you just slap on a negative sign outside of everything, multiply the whole thing by -1, then that's just a reflection. It's a vertical reflection, so I mean you go from up to down is a reflection about the x-axis, and again the only thing that is changing is the y-coordinate. You add the negative to the y-coordinate. So you see in all of these are all vertical transformations, and the x-coordinate stayed intact, it stayed the same. The only thing that is affected is the y-coordinate because it is a vertical transformation. So the only thing that is changing is the y-coordinate, the height of a point. Okay, and if you're modifying the graph from inside f, then remember that means you're doing things horizontally. So you're changing the graph horizontally. If you are doing something inside of f, remember it behaves the opposite of what you would think. So if you're subtracting a number, that means you add it. You're doing the opposite. It behaves the opposite. Um, and if the whole thing is negative, you move to the right. If the whole thing is positive, you move to the left. Okay. If you're multiplying by a number inside, then in the terms of the coordinates, that means you're actually dividing the coordinate. And this is a horizontal transformation, so it means you're dividing the x-coordinate. Now, for horizontal transformations, only the x-coordinate gets affected. The y stays the same. And if b is bigger than 1, then is a compression. If b is between 0 and 1, then it is a stretching. By how much? Well, if it's bigger than 1, it's by a factor of 1 over b. If b is less between 0 and 1, it is by a factor, still also by a factor of 1 over b, but the only thing that changes is whether it's a compression or stretching. Okay, and lastly, if you slap on a negative sign inside f of x, like that, then it is a horizontal reflection. Horizontal because it's happening inside f, so it's a horizontal transformation. Horizontal reflection about the y-axis, so you move from left to right or from right to left, okay? And the only thing that changes again is just the x-coordinate. The y stays the same. So here's a little bit of a reminder. If you are modifying f of x outside, that means it is a vertical transformation. If you're modifying the formula for f of x inside, so wherever the x is, you change that inside, then there's a horizontal transformation. If it's a vertical, it behaves the way you think it should, intuitively. If it is a horizontal type of transformation, it behaves the opposite of what you think it should do. So we're going to do one more example of a graph. So this is example 8, and then I'm going to cover example 7, and that would be the end. Okay, for this lesson. So example 8, we're going to sketch the graph of y equals -2 absolute value of x minus 4. Or another way that you could write this would be sketch the graph of f of x equals -2 absolute value of x minus 4. Remember, y equals f of x. This is standard traditional notation. So they can use y or they can use f of x. Okay. So this one, you see that this is a modification of the absolute value function. So that means we should start out with the graph of the absolute value function. So you should know what that looks like to begin with, and you should be able to sketch it and then use it as a model. So that is, again, one of the toolkit functions. One of the parent functions you're supposed to be familiar with. Uh, one of those graphs for which you should not need help drawing, right? That I told you you need to know. So here's the graph of the absolute value of x. It looks like a V, and those lines divide the first and second quadrant exactly halfway through. So it goes through 1, 1, 2, 2, 3, 3, 4, 4, etc. And then the other side, because this function is even, is a mirror image of the right-hand side. The left-hand side is a mirror image of the right-hand side. So with that, we're going to sketch here the basic function y equals absolute value of x. And that's going to be a starting point. Okay, so at 0, you get 0, that's the vertex of the V. You can use that 1, 1, or 2, 2, or 3, 3, or just any point in that graph. So that's going to give me one side. So I'm going to connect these. All right, and then the other side is the mirror image. So -3, 1, 2, 3, -3, 3. Okay, let's connect those, and then we have the basic graph for absolute value of x. Oops, oh, a little bit over. Okay, anyway, so that is it. That is the basic graph of absolute value of x. Okay, so now we're going to take this one and modify it and get to the new graph for this one that we have. -2 absolute value of x minus 4. Okay, by the order of operations, you start inside with the inside, and then the last thing you do is the -2, right? If you were trying to plug in here a number, you would do first the inside of this absolute value, and then the last thing you do is the -2. So that's the order of operations. So I start with the inside and then move outside. So the first thing then we're going to do is, and I'm going to do this in 2 steps. I think it is easier. You could do both at the same time. That's okay. But I'll do it in 2 steps. So first thing I'm going to do is I'm going to ignore the -2, and I'm just going to do uh, this other one first. Okay. So this one you do subtracting for that's happening. You see that is happening inside the absolute value function. The basic graph is absolute value of x. So you're subtracting 4, and that is happening inside, not outside of the absolute value. It's happening inside the absolute value. So the fact that it's happening inside means that it's a horizontal type of transformation, and because it's a horizontal type of transformation, it behaves the opposite way. So I'm subtracting 4, so instead of moving to the left, like the negative numbers normally do, I move to the right. So I'm moving the whole thing to the right by 4. So I'm moving the whole thing to the right by 4. So 1, 2, sorry, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that is the graph of absolute value of x minus 4. So I'm going to connect the dots. And that's the graph of this. Okay, now I'm going to apply the outside, and that means the y coordinate now get multiplied by -2. So now let's do that one. Again, you could do these two steps at once if you want to. Um, there's no reason why you shouldn't do it if you don't have problems keeping track of both things at the same time. In a table, uh, if you want to do it both at the same time, doing it this way would help. So you could do like one and then do the other one, and then you would have the dot right away, the new coordinates right away. So first, change the, do the first step. In this case, that one. So I'll do it. I'll show you what I mean. But you could do it like a table like that, and then do both at the same time. So I'll tell you what I mean. I'll do this one that way as well. Okay, so now I'm gonna do the other step, which is multiply by -2, and this is happening outside, so that means I take the y coordinate and multiply by 2, and that's it. And then we will be done. So take this y coordinate and multiply by 2. This is -3 multiplied by -2, that's going to become -6. So 1, 2, 3, 4, 5, 6. There. This y coordinate is 0, so multiplying it by -2 becomes still 0. And then this one is 3 times -2 is -6 again. So there. And that's my v. Okay, that's it. That's the graph, the new graph. So you see I'm multiplying by a negative number, so it is a reflection across the x-axis, is a vertical reflection. Okay, that's the graph of y equals -2 absolute value of x minus 4. Okay, so now I'm gonna tell you what I mean by how to do it all in one shot, if you want to. Let me see if I have some space here. Let me do it over here in another piece of paper. Okay, so let's do it in the form of a table, like that one, real quick. Okay, we only have 3 points, so this is not going to be bad at all. So the original 3 points, are what that I chose are -3, 3, 0, 0, and 3, 3. Okay, so let us apply both transformations. So remember, you do the order of operations, so you have to do start from the inside again. So first, subtract 4 is the horizontal transformation, so you're going to do the opposite of subtract 4, which is add 4. And this is a horizontal transformation, so that means the x-coordinate gets affected. So I'm adding 4 to the x-coordinate. So this is negative 3 plus 4. Negative 3 plus 4, that gives me 1, 3. 1, 3. Which is actually happens to be the coordinate we just drew when we did the first step. And now, but instead of going through the process of drawing the whole thing, I'm going to immediately figure out what is the final coordinate that I really want. And then I would do the negative 2 times negative 2. And this is outside, so it's a vertical transformation. So that means the y coordinate gets multiplied by negative 2 uh, instead of divided, because when you uh, this is vertical, it does what it's supposed to do. So that means you multiply the y coordinate by negative 2. So this is 1, negative 6. And that's it, which is actually the point that we drew. Good. Then you do the same thing. Uh, Now, once you do it once, it's really easy to do it for all the other ones. So what we did, we added 4 to the x-coordinate, multiply the y-coordinate by negative 2. Add 4 to the x-coordinate, multiply the y-coordinate by negative 2. Oh, sorry, this is 0. Uh, Add 4 to the x-coordinate, so 4 plus 0 is 4. The y-coordinate is the same, and then multiply the y-coordinate by negative 2. This is 0. Right, okay. And then add 4 to the x-coordinate, so that becomes 7. And then multiply the y-coordinate by negative 2. And there you have it. And now you would only sketch this part. And that's it. So you would have negative 1, 6, 4, 0, and 7, negative 6. And that way you don't have to go through the process of drawing an intermediate graph. You could do it all in one shot. Okay, so that's it. Now, lastly, we're going to do what we just did right here. What we just did right here without having to draw the graph. So it says, suppose you have a function and you don't have a formula for the function, you just have some function, and you suppose you know that the point 12, 6 is on that graph. Suppose you know that the point 12, 6 is on that graph. Question is, if you were to draw the graph of these transformations, where would the new point be? The corresponding new point on the graph under the indicated transformation. Okay, so in part A, we're adding 3 inside of the formula. Adding 3 inside is a horizontal transformation. Horizontal transformation means only the x-coordinate gets affected, so only the x-coordinate is going to change. And horizontal transformations behave the opposite of what you would think. So it's here it says add 3, so we're going to subtract 3. So that means actually it goes to 9, 6. Because I've subtracted 3 from the 12. And that is the answer for A. Okay, now let's do B. B has a plus 2. That's the starting point. B has a plus 2 that the plus 2 is outside of f of x. So that means that plus 2 corresponds to a vertical transformation. So that means only the y coordinate gets affected. And because of vertical transformation, it behaves exactly the same way uh, you think it's happening. And indeed, so that means we're adding 2 to the y coordinate. So this is going to be 12, 8. Okay. Okay, how about this one? Let's see. This one has a -2 that is being multiplied, and it is happening outside of the function. So that means because it is outside, it is a vertical type of transformation, so that y-coordinate is affected, and it behaves exactly the way it should. So that means the y-coordinate gets multiplied by -2. So this is 12, -12. Okay, at this point, I think you should pause the video and try D, E, and F on your own and see if you get to the same answer. Okay, now let's keep going. So, this one, where does the point 12.6 move? Okay, in this one, I'm multiplying x by 1/3. The 1/3 is inside of the function, so the fact that it's inside of the function means that it's a horizontal transformation, and that means two things: the x coordinate only gets affected, so only the x is going to be modified, and it behaves the opposite way of what we think. If I'm multiplying by a third, then I need to divide by a third. So I'm going to divide 12 by a third. Dividing by a third means multiplying by the reciprocal of a third, which is 3/1. So that means multiplying by 3, so this is 36. So you can put that in your calculator. 12 divided by a third is 36. Okay? All right. Now this one. This one has a negative sign inside. Inside means only the x coordinate gets affected because it's a horizontal transformation, and so this becomes -12.6. Okay, it's like you're multiplying by -1, so you do the opposite of multiplying by -1 is divide by -1. So you still get 12 divided by -1 is still -12. So that one, when you just add in a negative, it really just does just that. Uh, Slap on the negative. And that last one, there's two things that are happening in there. So this one, we're gonna do it in 2 steps, just like we did these ones. Okay, there's two things going on in there. You could do it all at once, but it's better to do it in 2 steps, so not to mess it up. Okay, remember the order of operations. You start inside first. Okay, so starting inside, that is a horizontal transformation. So that means in the first step, only the x coordinate gets affected, and you do the opposite. Instead of subtracting 2, you add 2. So that's going to be 14.6. And now we do the vertical transformation, which is multiply by 3. Multiplying by 3 is a vertical transformation because it's happening outside, and that means only the y coordinate gets affected because it's a vertical transformation, and it behaves exactly the same way it is indicating. So times 3 means you multiply the y coordinate by 3. So that means this is going to be 18 for the y coordinate, and now that is